Hello guys, so today I want to move it up on a positive notch and do a mining tutorial. A lot of you have been asking me to do it, so let's do it. So anyway, HEXX coin is a proof of work cryptocurrency, so the main aspect in receiving new coins is basically mining, or that was the initial idea. So if we check the website and scroll a bit down, you can see here that HEXX coin includes or runs on a proof of work algorithm called Lyra 2Z330. So this is a CPU mining algorithm. It's GPU resistant, it's ASIC resistant, and basically you need just a CPU to mine it. Okay, so let's proceed. So how can you mine? How can I mine? So first things first, let's register on pool. I've selected the chain silo pool, the pool number 2. So there are two pools, pool number 1 and pool number 2. I would suggest pool number 2 for now, since the pool is hosted on Google servers, so um, expect no downtime from there. Yeah. Okay, so first things first, you need to go to chain silo pool and register. When with that, you're gonna get a username, or you're gonna set up your username, and once you do that, you go to my account, my workers, and you add a new worker. So to start mining, you need to register here, get your username, and get your worker name, and worker password. So after this is completed, you can then proceed on the next step, and that is to download the miner itself. So I'm gonna include all the links in the description below, but yeah, so miner, here we have the CPUminer opt and version. So this is the most optimized miner for CPU mining, and you can get it here. For Windows, it's the simplest, since it's already pre-built, so you just download the zip file and you're almost ready to go. So again, downloading this file gets a warning from Chrome, since all or the majority of miners or executables are marked as malware or viruses these days, since in the past there have been a lot of attempts to just use your computer to mine maliciously. Yeah, okay, I can't pronounce that word, but yeah, maliciously. Yeah, maliciously. Here, I've done it. Okay, so I've used pretty much all versions of CPUminer opt, and I have never had any problems with it regarding security. So this is just things operating systems do these days. They don't want you to mine. But yeah, so here you can see I tried to download it and it's not allowing me. So you need to open the download section, and here you can proceed by keep dangerous files. So yeah, keep anyway, and it's actually gonna download. And here again I have McAfee advisor that this file is dangerous, but yeah, accept the risk and download it. Yeah, so once it's downloaded, you can extract the file, and you're gonna find a number of executables. So if you run an executable, nothing is gonna happen, or Windows is gonna try to protect you or whatever. You can't run the CPUminer in its own just by running the executable. You need to create a batch file and run it through the batch file. But here, even now, I got protection. So let's allow it, and yeah, if I do it now, it's gonna work. Okay. So as I said before, the majority of CPU miners or miners in general get flagged as malware by the antiviruses. So you just got to uh, allow it to keep on using it. So anyway, in the zip file, you're gonna see a number of different executables. So you need to choose the one that is best for your CPU. So if you read in the CPU miner opt readme file, there's a bit of explanation. So depending on your architecture or the architecture of your computer, you need to pick the right CPU miner. So we have CPU miner SSE2 for Core 2 and NAILM processors, CPU miner AES SSE42 for Westmere and Sandy Bridge, Ivy Bridge processors, CPU miner AVX for Sandy or Ivy Bridge processors, CPU miner AVX2 for Haswell, Skylake, Kaby Lake or Coffee Lake processors, and CPU miner AVX2 SHA for Ryzen processors. So for Ryzen, go with this, and for Intel, pick one of these. Or even for the older AMD processors, you need to pick the first two. Okay, so anyway, once you find the executable that is right for your computer or for your processor, you can proceed. So for me, it's CPU miner AVX2. Okay, so if we return back to the folder where we have the CPU miners, we need to create a text document and end it with a bat ending, so it's a batch file. By default, Windows hides these extensions, so you need to enable it in settings. So if you go View, Options, Change Folder and Search Options, and then under View, you scroll a bit down, or here you can see it, hide extensions for known file types. Usually this is enabled, so just disable it so you can change the ending on a textual file. So let's say you go right click, new text document, here new text document, you type mining or whatever, so a batch file name, and then rename it, and just the ending you just rename to bat, and this could be your starting file. So here I already created mine. If we go check it out, so the first thing you need to type in this file is actually the name of the CPU miner you're going to use. As I explained here, so depending on your CPU type or CPU architecture, you need to choose the right one and then proceed with this info on the file itself. You can get the basic file content on the pool itself. So if you go under help and getting started, you can copy this string and use it in the file itself. So if I go back, no, not this one, but here. So sorry. So you started with a CPU name, or if I just paste this from chain silo, so you need to patch this first part. You need to pick the right executable and then just continue with info at the end. So as I said, when you register on chain silo, you get a username, and then you need to create a worker and get the worker name and worker password. After that, let's say if I don't add nothing and I start the miner. So you start the miner not by running the executables, but by running the batch file. So now that this is saved, I can double click it, and the miner will start. Now, because I have not defined the thread limit, all of the threads on my CPU start going to 100%. So if I check just on the task manager, my CPU is burning up. So here, if I go under performance, you can see all of my cores are at 100%. So this is actually not good for mining HEXX. If we stop this, so, and maybe just put down a couple of words on HEXX algorithms. So Lyra 2Z330. So this algorithm is based on fast memory, and I'm not talking about RAM or video RAM, so like DDR3, DDR4, DDR5 memory, but this is actually made for the CPU internal memories, and that is called L2 or L3 cache. And the bigger the memory size of that on your CPU, the more hash you're gonna get, or the better mining performance you're gonna get. So if I just check the how this cache actually looks like in the processor itself. So here we can see the CPU cores are apart, so they're separated, and in between there's this L3 cache. And each CPU core actually has the access to any part of the cache itself. So the core count is not really that important. The most thing that it is important is the size of the cache itself. So if I go back to my processor, it's got 6 cores, 12 threads, and 9 megabytes of L3 cache. So yeah, and a majority of this cache can be accessed just by one thread. So if we go back and start mining again and just do some basic calculations. So if I start mining, 12 of my threads, or all of my threads, go at 100%. And if I just wait for basic numbers for the first hash rates I'm gonna get, you need to wait a second or two just to get the first responses on the mining or the hash rate. Now give it a second here. Okay, so let's pause this. We can see at the average hash rate on one thread is around, so 10, 30, 20, let's say 22. And if you multiply 22 by 12, the combined hash rate would be, or will be, around, let's say 300 or 300 and just something over 300. Now if I try mining and limiting the thread itself, let's say at the end of this batch file I type in thread limit and a number, so let's say thread limit and 1, and I start it. You can see from the task manager that only one thread will be utilized. So if we wait a second, which thread will it be? One should be going to 100%. Okay, I'm not seeing it. Not yet, at least. Okay, let's wait for the miner to do or push some more work. I can't see no thread utilized, but yeah, it's CPU 0 and it's 478 hashes per second. So if you remember from before, when I was using all of my threads, I was getting actually the lesser hash rate than I'm getting now by using a thread limit. So this is actually a HEXX algorithm speciality where you actually use a smaller percentage of your CPU and get better results. So depending on your CPU and depending on your L3 cache size, the thread limit needs to be set up and you're gonna get the most of your CPU out. Now there's not a really a calculation or a fixed method to achieving it, so it's pretty much trial and error. But anyway, for my CPU at the moment, the best hash rate I get if I just limit the mining to one thread. I can now also try maybe 2 threads and just see how much I'm gonna get then. So I put it to 2 threads and I start it again. So with one thread I got around 480 hashes per second. I'm currently also streaming from this computer, so the hash rate is not ideal, or it's not the maximum I would be getting if I wouldn't be using my computer for, let's say, streaming or running the browser and whatnot. So I'm mining now on 2 threads, and let's see how much hash rate I'm gonna get now. Again, here we can see now, so there are 2 threads utilized, and from the task manager it's pretty simple to see that it's CPU 0 and CPU 1 fully utilized. All other threads are normally utilized. So let's just wait for the hash rate to build up here. Again, it takes a couple of seconds or sometimes even a minute or two for the hash rate to be displayed on the miner itself. But as long as you see it in Task Manager that the threads are being utilized at 100%, you know the mining is working. Just give it a second to spit out something here. So if I pause this, or if you just calculate quickly, so the 2 threads combined together mine just under 400 hashes per second. So with my first attempt where I was using 1 thread, I actually got more than 400. So with me, this search for the best thread limit is already set then. So I use just 1 thread and I'm gonna get the most of my CPU at the moment. This thread limit actually corresponds to memory or the speed or the lanes of RAM you're using. If I move my thread back to 1 and start it again, you can see that even though, let's just find the, okay, so this is the miner. So even though the miner doesn't use a lot of memory or RAM, it uses a small part of it, and even this small part of it can play a big role in mining. So currently here on my computer I'm running only one stick of RAM, and by adding another stick of RAM, this bandwidth of this small amount of memory would be doubled, and by doubling this memory latency, I would also get a boost in mining performance. So maybe then by using 2 sticks of RAM, I would then need to move my thread limit to 2 threads. But I'm gonna see this in the future when I apply another stick of RAM. Okay, enough about the thread limit. Let's continue with the what's it called, CPU affinity. So here I've done a basic file on it. So what is CPU affinity? So when you remember back when I'm limiting my threads, you can see from the wait, now I've closed it. Let's open it again. So if I run this, when I'm running the miner and limiting the threads to 1, it's actually assigning the first available thread to it. So if we check on performance, it's going to be first or the second thread is going to be utilized or whatnot. So by using the setting CPU-affinity, you can actually define which thread you want this miner to use. And let's say if I wanted to use the last thread, I would need to define it with CPU-affinity. So how do you define CPU-affinity? First, you write down the number of zeros for each thread your CPU has. So my CPU has 12 threads, so I'm just gonna write down 12 zeros. Now if I would want to force use the first thread, I would type 1 here, or if I would want to use the last thread, I would type 1 here. So this is just a binary representation of the CPU mask. So if you type 1, that means that thread number will be utilized, and if you type 0, it means it's not going to be utilized. So let's say I want to use the last thread on my CPU. This would be the CPU mask. Now this is a binary number, and when specifying CPU affinity, you need to use a hexadecimal number. So we need to convert this binary number to hexadecimal number. So how do you do that? If you have some basic computer knowledge, you can probably do it from your head, but if not, there's a simple website called BinaryToHEX converter, and you just paste this binary number and it converts to a hexadecimal number. So I'm gonna now copy this hexadecimal number to the settings. So CPU affinity, and then I type 0x. 0x means it's hexadecimal, and then type the 800. Okay, now I save this, and if I run the miner again, and if I check on the task manager, the last thread should be utilized. So as I've said, I've defined the last thread to be utilized, and it's perfectly seenable here under the task manager. So yeah, what is weird that now I'm getting a really small hash rate on this one thread. So you need to take care when defining these threads or the CPU affinity. In some cases you're gonna get worse results than by just not using it at all. But yeah, here I can already see my mistake. I've defined only one mask, but I'm using 2 threads. So you need to match the thread usage with the CPU affinity. So here I'm using only 1 thread, and I should be using 2 threads since I defined it T2. If I go back to this file and we check, so here I've defined 2 threads, I should be using 1 thread and this CPU mask. So let's close this and then run it again like so. And if we check on the task manager, the last thread should be utilized, and that is correct. And only 1 thread should be used since I've defined the thread limit to 1. Okay, now let's just wait for the numbers to come, but it should be the same as before, just above 400. This is maybe a bad example since I'm using only 1 or 2 threaded mining. It comes in usage with more threads or with different type of CPUs. I have open here a Xenon CPU that is or that has 32 threads and 40 megabytes of cache. So here, if I just type, let's see, or htop, we can see that, so this is a Linux PC, and I've limited the mining threads to 6 out of the 32 threads, and with this I'm getting the most performance out of it. If I just print the mining performance, so it's actually mining at 2111 hashes per second, and all of this just because I've limited the threads to 6. If I would be using all threads, the hash rate, the combined hash rate would be much lower. So you need to find the sweet spot depending on your CPU. Here I've used just the thread limit 6, and that works the best for this CPU. Okay, so maybe if we do just another example on this CPU affinity, and maybe using this 32 threaded CPU, it would be much more showing. So let's say I want to use a number of threads, but not threads that are next to each other. If we look again at the classic CPU die, using CPUs that are close together is just gonna make heat heat spread just from one part of the CPU. It's much better if this CPU usage is shared. Let's say use this CPU, use this CPU, and use this CPU. So once those CPUs go to 100%, the heat is actually going to be spread out to more of the die. So the heat from this will go around here, and this one around here, and this one around here. So from this view, it's much better to use CPU affinity and spread the usage on the CPUs. So in this example where I have a 32 threaded CPU, so I've written down first 32 zeros, and then I just type 1 on the threads that I want to enable. So let's say 1, 1, 1, 1, 1, 1, and so it's 6 threads. And I copy this binary number again to the BinaryToHEX converter website. I convert it and I get this hexadecimal number, and then if I go to my Linux miner, let's say I'll just kill all CPU miners first, and then I just patch this miner, and I type CPU affinity, and I type 0x and paste this number I got from the conversion, and I run this, and let's see the response now, or maybe even the CPU usage. So you can see that the CPUs used now are spread way around the actual CPU. So they're not just concentrated on one end, but they are spread out. So with this, the actual CPU temperature should be much lower, and I should also get better performance. So if we see now the hashes per second, so if you have a multi-threaded CPU, it takes some time for all the CPUs to get called out, or the hash rate to be calculated together. So it takes some time for this full hash rate to be displayed on the display itself. So if I just run the htop command again, I can see CPUs are at 100%. That means it's mining correctly. I'll just wait for this hash rate to build up. But yeah, anyway, while the hash rate is building up on the miner itself, you can also check it out on the pool website itself. I'm using now 2 servers here, and the combined hash rate of both servers is around 4 kilohashes. If you go back to this, okay, so the hash rate is building up. It's approximately 350 hashes per second per thread, and since I've limited to 6 threads, we can just simply multiply. So 6 by 300 is 1000 806 by 50, it's 300, so 2100 hashes per second. So yeah, that was actually the same number that I got before. But anyway, in some CPUs, it really brings a price or performance boost by using the thread limit itself and by using the correct CPU affinity. So I can't really tell you the perfect formula for it. So I think it's just trial and error, just depending on your system build, depending on the RAM sticks you're using. So depending on, are you using single channel RAM, dual channel RAM, or quad channel RAM, depending on that, you're gonna have to set up the thread limit and of course the CPU affinity if it actually helps in itself. So depending on the CPU size or the temperatures you're getting. So I think that should be it for now. So you register on pool, you download the miner, you create the batch file, you edit the batch file with your pool info, and you define the thread limit, the CPU affinity setting, and you should be good to go. So you just set it up and you run it, and that's it. You can minimize it and leave it running in the background, and you just get HEXX payout every day. So I hope you've learned something today, and let's do this in the future. Yeah. Thanks for watching, and bye bye.